In modern 3D rendering, polygon count isn't as much of a performance bottleneck as it once used to be. Modern GPUs are able to render hundreds of thousands of vertices every second without breaking a sweat. Instead, the latest issue plaguing games trying to achieve the best possible performance is draw calls. Before each object can be drawn by the GPU, it has to be processed and packaged by the CPU. This data is then forwarded onto the GPU, telling it what to draw, where to draw it, and what it should look like. This is known as a draw call. But the CPU is notoriously magnitude slower than even a basic GPU, so too many of these draw calls will just completely destroy the performance of your game. You can't avoid draw calls altogether, but by minimizing them you can free up a lot of resources. To minimize the time spent processing and sending data to the GPU, you can batch draw calls together and send them to the GPU in one large packet. This is more efficient than sending lots of little packets of only one mesh or one texture each. This is where SkinnedMesh Combiner comes in. Combining meshes is a great optimization tool, and Unity comes with its own method for this. Only problem is, this method doesn't address the much more complicated skin meshes. Bone weights, blend shapes, and textures all get left by the wayside, so I've created this tool to perform all of these operations for you and more. Once you import the SkinnedMesh Combiner package and identify the meshes you want to combine, add the component to the parent game object of those meshes. From here, you can use the auto detect button, which will attempt to locate all the renderers you wish to combine and set the proper settings accordingly. In most cases this is sufficient, but of course you can manually modify the settings at any point. It's important to note that in this setup, the first renderer successfully processed will define the pattern for a few properties going forward. Things like the texture resolution, as well as the armature you wish to bind everything onto. If you're using a character mesh, as I am in this example, typically any body part will suffice as a template for the combined mesh. Next, you choose from a set of predefined combine modes with similar but specific differences. Combine and Replace will replace this game object and renderers entirely with a new combined one. Combine to New will create a completely different game object for the combined model and will leave the source unchanged. Combine to Prefab will export the combined model into an editor asset in your assets directory. Below that, Combine on Start is a special option that will trigger the combination process when you start the game. This is a useful debugging tool, as any change made when starting the game will be reversed on exiting play mode. However, this should not be relied upon in the final build, as mesh combination, especially with a skin mesh, is an expensive process and will noticeably slow the game down when starting up. Once you're satisfied with how the mesh combines, you can bake it into either an object or a prefab for later use. This is a pretty advanced application of Unity skin meshes, so if anything goes wrong or if you have any questions, feel free to get in touch with me either through the comment section here or through my Unity publisher page.